Okay, so I just got done with the review a little bit. I want to get some detail in here. I wanted to post this stuff actually up before I started this video because then I don't have this. Like I said, and the reason I would do this is because I wanted to put this M2 because this is actually what you see first, but you need this stuff on the paperwork first. Like I said, when I'm playing the ZBrush out here to, well, let's click that file and throw it into total time about what Carl Sagan and Fogg nuking Mars may look like. Side here, well, you want to get comprehensive with me? I mean, I'll get this with you about some stuff. I'm not necessarily quite this way, but Bernoulli's in field theory to set up a field equation, to set up things on a black body radiation problem, a tweet, sometimes it's a little bit of this, or which one I would choose inside here about going through this and listen to this and some post-ups on, well, I actually chose the trumpet, or the chariot, the 7th, I usually play it like Mike, the Pipe Piper, Running Lou, and 42 over here, Matthew, Mike, whatever's usually at the man or on that high side because it gives me gravity. If I see you playing Mike, it gives me a standard model of it, realistically, when you think about it. Now, amongst the standard, in the fucking cyclotron, you have a different damn standard about what stuff is and when stuff is what stuff is, given the 42. Let's go on. No, those are real. Like, I deep fake it, like I said. Make the clip, you got Bumblebee. All of a sudden on the Terminator, or the Transformer HUD cracking the Pentagon, and that way function black body, the number of mentions, electromagnetism, across different spectrums. You tap in strong force, through the weak force, up and down on the index, the gravity, electromagnetism, changing of fields to say photon, magnetism, in a field close together, make it a hot. -1 cold, hot, cold, particle right there. Some index can space-time through Pensrow through certain sheets of paper, again to the compression, down to 2 neutrons next to each other, and to the point of black hole, IH. The number we're still using is going to be, again, page after page, step after step. I wanted to kick in a few notes here. Those would have been the first few of them. But I still got this is still going to be a field. Well, it's got a little bit of stretch to it here. You see, and if I were to take this and pop it up into the box, then I got this being a snowflake. And let's shift off these angles to say here and here. And this is some stuff you see quite frequently in field theory. Like, this is a laser beam right here. I'm going to amplify that laser beam and test you students on what? Amplifying lasers, because it's a bunch of sectors inside of there where it's useful. So it generalizes the sector. I'd say inside of this dimensional analysis, let's say I call a name here, I call a name here, I call a name here, and the X line is wherever I want to put it to the Pensrow on the slide of those equations. Let's say I give it I, sigma sum, or infinity, sigma sum. Those matrices work the same way, right? And this thing becomes sigma, right? And I'm on the right-hand rule. I know I must be in the positive here. If I'm choosing to build something on an autonomous program like that, let's say this is Johnny's line, this is my line. I have an index in the field when I do the geometry for this, because they do form partial models of, again, actions of spooky distances of days is the M2 phase first. But it graphs off of this, but you kind of use your imagination a little bit. Nuclear snow on Bikini Islands, turn it into ball bearing factor, or just being in the ball bearing factor, pretending you're in Bikini Islands, which has nothing to do with bikinis. At this point in time, that vector position is going to have a lot of nuclear project blue book of sectors inside here. These are tighter, compressed systems in physics by IH. IH, derivative U, derivative. So I slide through all of it in there, but without something physical. It's usually where I go this next, but he's going to move through theses. I think you got to touch on Bernoulli a little bit. I think when you get good with riding Bernoulli, Elon, telling about Facebook, well, kids on the money of the weights and plates inside of the sectors, your fire starting bullshit, starting some problems based on some realistic numbers of your team moving. Now, if you hit that on there and it graphed on a collision ratio that or it's starting to look like that, or it shifted your decisions. Shifted
It's a
the
phase
word.
shift. That's all it is.
Phase shift's
But
good.
what
What?
our
Yellow
domain's going
phase,
to be is
blue
every
phase,
place where we had
red
an
phase,
x
red, white, and blue
intercept on
phase.
cosine, we now got a
You
vertical
know, that's going to
asymptote
go
for
right
secant.
off one,
That happens
yeah,
at
right to
pi
0.
over
But I
2
don't know whether I'm in that
plus
phase or not,
k
because
pi.
even though
So
they're in red
plus
phase,
pi
they're
over 2
still in
plus pi would
quarantine,
be
right?
here.
The rules of
Pi over
that
2
black
minus
body
pi
still apply.
minus another pi. We're
They
going to get a vertical asymptote at all those
X,
things. So
this
let's write that
number
out. Our
0
domain
plus
says,
this is
yeah,
something
because it's
by
based
dimensional
on
analysis. I'm
cosine,
starting one back,
because
one
x-intercepts
forward.
happen at
F1
pi
plus
over
F2
2,
equals minus
and
F1,
every
turns into gravity
plus
stuff,
every multiple
turns
of
into
pi,
topology
we
stuff.
say that
People,
x
there's a
cannot
lot of people
equal
in
pi
there,
over
not just
2
Newton. Now, Newton needed a coalition of people who agreed with
plus
that
any
theory,
multiple of pi.
positive
That's
one
going to give us some
indexes,
problems. It's going to
that
give us x-intercepts
arbitrarily
for
will graph
cosine,
math,
and therefore
astrologists,
vertical asymptotes
physics,
for secant.
they
Our
graph
range is
numbers.
the same
Excel
thing
did.
that we got for cosecant x.
Which was X and Y. I made a choice. Which was B and Y. The definitions in terms of, well, it's all of those places. Well, mathematically, to do it, you would need
And so's our period.
at least
Because
a
this is based on
volume of a
cosine,
beaker that's
a period of
absolutely
2
the
pi
same in some
is
way
the
to measure
same
that
for
X,
both,
Y. So let's go back to X0,
cosecant, sine,
yeah,
secant, and,
plus
and
K,
cosine. So
KT,
they all have the same period there.
K pi.
Now it looks a little funny because the period here cuts our graph right in half. So that's a little bit awkward. A lot of times we're going
The
to
snake, the
kind
beast,
of
and the
think
dog
of
pharaoh,
this
20
as
silver pieces
one
under denial,
one
talking about
period,
Solomon's
especially
fall,
when we
chasing
have,
too many rabbits.
actually for inverses we think about it a little bit differently to cut it so it's 1 to 1.
Cut down that
But we
math
can
problem.
sort of alter
Change any of the speeds, velocities, votes.
So anyhow, our period is 2 pi, and the key idea here is that
Well, it's
this
still
is based on
singularity.
cosine.
It graphed 1
What that
to
means,
2,
because
but
the
I
reciprocal
can't
function
without
is that
Andromeda
where we had
paradox,
x-intercepts
right?
on
Because
cosine, we're now
Tony
gonna
Stark,
have
Jarvis got
vertical
dead, Bruce Banner walks
and that's
in and goes,
really
wow,
about
this is
it.
benevolent.
So what I'm going to show you now is just two
tore it
examples
apart.
of how we can do some transformations with cosecant x and with secant x, and I'm going to base them on
Just
sine
me.
and cosine.
Kill as many rabbits as I want and die
All right,
whenever
let's do
I
an
want.
example about a transformation. We'll have one more after this one. Let's take a
Certain
look at 4
fence posts
secant
on
1/2 x. Here's the first thing
front
that
of
I do.
Cerebro here.
Because I'm so very comfortable with cosine and sine, what I do is I graph the
This is a nuclear reactor,
that is the whatever the
but
reciprocal function is.
If
I
I knew the
pretend
feeds and
that is
speeds,
cosine
it would be
for
alright.
just a
He
second.
could get through
I
it.
graph a dotted line
He's bigger
version
than I am.
of
He's going to close the
cosine,
deal.
and then I
Bar
reciprocate.
at the bar.
For
Should
me,
I
that's
H
a
on
lot
the floor?
easier
Let's say it
than
is a
actually trying
woman
to
on the
remember
floor, and
what
we were
secant
in the
looks like
collision
and
of what
where
happens
that
here.
period is.
If
In
he
my
knew my
head, that's quite hard
backlog,
to do,
he could tell me I'm
or at
single.
least it
You're
used to
not.
be.
This
And
is
so this is the way
blockchain by
that
any
I
other
practice
standard,
doing that.
by
And so
setting
what I'm
up
going to do
the
right now, I'm going to
equation, the
pretend
Bernoulli's
that's
pipes.
cosine 1/2
Through
x.
the
Now,
mathematical
it doesn't help if you can't
gates.
remember that secant is the reciprocal of cosine and not sine. So that is a
He's
problem.
going to say
I've seen a lot of
if
students
X, because
forget
the
and
vote
do
of the people,
cosecant is
whether
the
it be the
reciprocal of
bigger
cosine because they
momentum.
both
Now,
have co in it.
that's where
It's not,
Prometheus
it's
and
opposite.
blockchains
So
and
the
marriage
reciprocal
to
of secant
husbandry
is
of the
cosine,
danger
the reciprocal
noodle.
of cosine is secant. And so I'm going to
Catch you in the
draw
next one.
4 cosine 1/2